Hello everyone, welcome to our channel Code with Sunny, and in this video we will be talking about the problem partition labels. Its index is 763 and it is the medium problem of the LeetCode. Okay, so we are given a string S and we want to partition this string into as many parts as possible so that each letter appears in at most one part. Okay, so that is, suppose you have the character A, then this character A should be present in only one part of the partition that we are going to do. Okay, we need to partition our original input string into the as many parts as possible such that each part will contain the specific character. Let's call it as C. Then all the occurrences of the C in the input string S must be containing in this part. Okay, if you're not understanding this right now, no need to worry about it. We will take an example and I will explain how we are going to do this. Note that the partition is done so that after concatenating all the parts in order, the resultant string should be S. So we need to partition the strings consecutively, like first one from 0 to some index, then index plus 1 to another index, and so on. Return a list of integers representing the sizes of these parts. Okay, so let's look over the constraints. Also, you can see strings length is 500. So yeah, O of n square solution, even O of n cube solution may pass, but we will be focusing on linear time solution. Okay, and you can see the approach that we are going to use is the greedy approach. It is not like a very hard one. You can think about that, how the sequence of operations will be performed. Okay, so let's take this input string and we will understand this one. So let me write down first the string a b a, then we will be having bcb, then we have aca, then we will be having def, then we would be having gdehi, then we would be having jhklij. Okay, so this is the input string that we have been given, and we need to partition this string into as many parts as possible. And suppose the character C is present in this, let's say, partition string 2, then all the occurrences of C, all occurrences of the character C in input string. Okay, so let me write down clearly. In input string must be present in this part 2, must be present in part 2. Okay, so let's take an example and understand how we are going to, like, what is the actual meaning of this entire statement. Okay, so like the example that I've taken over here is this long string. Suppose we will be starting from the very beginning. You will encounter the character A. So when you will encounter the character A, what does it mean? It means that the partition that we are going to take right now must contain all the occurrences of A. It means that all the occurrences of A is going to say that we need to include the last occurrence of the character A also. Last occurrence of character A also. So what is the last occurrence of this character A in this string? You can see this is the last occurrence of this character A. So it means that you need to include all the characters, all the strings, all the characters up to this position. Like for now up to this position. Okay. So when you will move forward, you will encounter the character B also. Okay, so when you will encounter the character B, it means that you need to include all the occurrences of B. It means that last character of B in the input string must also be included. So when you will find out the last character of B, you will say that yes, this is the last occurrence of this character B. Okay, so you need to include all the characters up to this position also. But you can see the last character of A is still greater than this last character of B, so your iteration will go up to this position for now. Okay, so when you will move out to the next position, you will see I have the occurrence of A, so we are already done with the character A. Again you will move to B, then you will move to C again. Okay, so when you will encounter the character C, it means that all the occurrences of the character C must be included in the current partition that we are going to do. And if you will find out the last occurrence of this character C, you will end up with here. It means that all the characters up to this position will be included. Okay, so what about the case like C will end up to this last position, let's say at this position. So that is the last occurrence of the character C is the end of the input string. So in that case, it will signify that we need to take all the occurrences of the character C. So you can see this end position now, which is the maximum end position so far, will be extended to the entire input string because we need to cover the character C also. Okay, so that is the main key point that I want to discuss over this here. But here in this sample, C will end up to this position. So you will maximize the end, like ending state of this. You can see the sliding window. Actually, you can see the start of the window will be up to this position, and end of the window is up to this position. So your end of the window maximum position where the window ends will be at this position where the character A ends. Okay, because the character B ends over this position and C ends over this position, all the occurrences of the character A, B and C will end up to into this string. Okay, so we are done. So what about yeah, so we need to store the length, which is 9, I think. 1 2 3 4 5 6 7 8 9. Okay, so we need to store the 9 into our answer. You can see one of the answers in the very beginning is 9. Okay, so we need to move on to the next part. So we are already done with this part of the string. We are already done with this part of the string. Okay. Now we need to move forward. So you encounter the character D. So when you will encounter the character D, initially your window is up to L is up to this position and rightmost position is R up to this position. When you will encounter D, you will have to include all the occurrences of D in the current window. Okay. So you will look out for the last occurrence of the character D in the input string. You will find D is going to end up to here. So what you will do is you will extend your R pointer up to this position. Okay, now again you will move out to the next one. You will encounter the character E. So when you will encounter the character E, you will look out the last occurrence of the character E and will try to maximize the sliding window rightmost index. That is the current sliding window rightmost index. You will encounter that E is ending up to this position. So you will increment R to this position. So you will make R up to here, and again you will encounter the character F. Now last occurrence of F is still at this position, so R remains as it is. Now again you will encounter the character E. You are done with E. Then you will encounter the character G. Okay, when you will encounter the character G, its last occurrence is still at this position, so R remains as it is. And when you encounter D, it is done. E, it is done. So you need to take this partition. Okay, so I think the length is coming out to be 7. If you look out the sample, one of the answer is 7. Okay, so you are still done. You are done up to this part. Okay, now again, you will look out the character H. Its last occurrence is over here. So your L is up to this position and R is here. Now you will look out for I. So I last occurrence is over here. So you will try to maximize R, which will come out to this position. Then you will encounter J. You will see that J ending index is the end of the input string. So R becomes here. So you need to take out this entire string. So its length is coming out to be 8. So you need to append 8 to your answer. Okay, so this is the entire step we are going to do. Okay, so how we are going to implement all that efficiently? So we will be taking some previous variable which will denote the, you can see, which will denote the index at which the last partition ends. Okay, so we will initialize previous as -1, and each time we will start our pointer, left pointer, which is I, as previous +1, and we will try to maximize our right pointer, which would be which I will be calling as end index, each time when we'll iterate from I to end index. Okay, so if you are working upon this position, let's say, so you will your I will be 0 and end index will be last occurrence of this character A. Okay, so which will come out to at this position. and each time when you will iterate from I to int index, you will try to maximize this int index variable as int index equals max of int index and the current character that you are working upon, which is last of s of I minus the character a. Okay, so this is what you are going to do. So let's look at the implementation, how we are going to do that efficiently. Okay, so n is strings length, and last we need to store the last occurrence of each character, and we have this answer which will be stored, which will store the answer. So we first will iterate in the input string and store all the last position of each unique character, and we will initialize previous as -1. So while previous is not equal to n minus 1, we will start working on each partition. So I will be assigned as previous plus 1, and int index will be last of s of I minus a, that is last occurrence, last position of this current character in the input string. So we will go up to int index, and each time we will try to maximize the int index such that each unique character must be covered in this partition, and each time we will increment I. And finally you need to push out the length, which will be I minus previous minus 1, and you will change the previous as I minus 1 to work upon the next partition, and finally you need to return the answer. Note that the time complexity of this entire solution is still O of n, because we are iterating each position of this input string exactly once. So O of n, and space complexity would be O of 26, which you call it as O of 1 also. Okay, so if you guys have still any doubts, you can reach out to us through the comment section of the video, and thank you for watching this video.